Hello, everybody. For our paper review, we've chosen the topic on a Kubernetes CI/CD pipeline with Asylo as a trusted execution environment framework. We are Group 7, and these are my members. I'm Zunaira Khan, and I'll be doing the introduction and design of the proposed model in our paper. So to begin, we first have to understand what is Kubernetes and CI/CD pipeline. A Kubernetes is a cluster-based distributed applications platform which is used for automating software deployment, scaling, and management. So usually in artifacts may not be protected from outside observers or cloud providers during execution. Such problems have been identified in the paper and it has been tackled by first making the pipeline support strong partitioning development security, which reduces the need for a human interface, and the resources are scoped to a Kubernetes cluster for public cloud providers. The deployment artifacts are secured with Asylo, which is where the term Trusted Execution Environment, TEE, comes up from, a development framework. This use makes the deployed artifacts in this model unique compared to prior work. So we know the commercial software development pipeline are divided into two stages, the continuous integration CI and continuous deployment CD. In this paper, Tecton has been used. So CI deploys artifact to create containers managed by an operating system kernel. So this automates each successive action in the pipeline from building the artifact to storing it for future use. And then we have the CD, which deploys artifact into running production system. So this execution begins instantly, and if it does not, the pipeline fails and execution stops overall. So this helps to create an automated or semi-automated pipeline, which ensures the overall security against known attack vectors and enables the pipeline to be more portable across multiple service providers. Asylo, a TEE framework, ensures the confidentiality of deployment. Thank you. That's all from me. Moving on to our next team member for the further discussion.
Thank you, Zunaira Khan, for your presentation. Then my part is implementation of the paper. In the implementation, they use a variety of open source software and commercial cloud service to implement the pipeline, GitHub. Firstly, they use GitHub. GitHub is a service popular with software developer that exposes a way to centrally host Git repositories online. An access token allows system to authenticate and be authorized to perform repository actions. Using this token, a webhook sends an HTTP post event to the URL endpoint of a Tecton event listener whenever a git push command is sent to the master branch of the repository. The event listener triggers the CI pipeline upon receiving the event. So the Tecton is a powerful and flexible open source framework for creating CI/CD systems, allowing developers to build, test, and deploy across cloud providers and on-premise system. Tecton Triggers is an open source event trigger library, especially architected to work with Kubernetes. So then the Kaneko, their CI stage uses container artifacts from open source Kaneko project. Kaneko differs from previous Tecton object. It is not a system of container that lives as a CRD within the Kubernetes cluster, but a simple container artifacts that deploys to the cluster as an executing object. Then part is Asylo. Asylo is an open source project that provides a framework to develop binaries that will execute in a processor secure enclave or TEE. A completed Asylo artifact is a binary that targets a specific processor architecture. This binary is not inherently set up to execute correctly in the context of a container or Kubernetes cluster. Then hardware. Kubernetes requires that containers to be deployed to the cluster come from a known and secure container registry. The most popular framework for this is Docker Hub, a publicly available registry provided by Docker. Hardware allows organizations to deploy and to secure their own private registry. Then the evaluation part. Their primary focus is the security of CI/CD pipeline through the least privilege and the security of artifacts by specially targeting RTE for artifacts execution. First, they use separation of duties. So it is one of the core tenets of modern security practices is the concept of least privilege. The core component of their pipeline is the development aspects of DevSecOps. So dev means developer. These individuals are responsible for writing code while they may be able to develop, test, and deploy locally in test environment. Sec, that means security. These individuals are responsible for attesting to the security of the code and deployment artifacts in the system. Ops means operations. These individuals are responsible for maintaining finished secure artifacts in production. So then securing developed artifacts, an often overlooked security that stems from the infrastructure provider. Consequently, processor manufacturers introduce secure enclaves or TEEs in order to secure code in processes from even the infrastructure provider themselves. So that is my part. The rest will be presented by teammate. Thank you.
Thank you, Tariq bin Shams, for your insight on the evaluation. Now I will be continuing it. I am Mahid Atif Hussain. So, first of all, let's talk about the cluster scope resources. What this means is that each part of our infrastructure only has access to the parts that it absolutely needs. For example, the developer only has access to pushing and pulling of the code. It does not have access to our images. This also means that our whole infrastructure can easily be migrated from a specific cloud provider to another without any delay. And we are even able to offer this service to air gap systems. This is very crucial for governments where their infrastructure is highly secured and they they deploy their they deploy their systems in air gap systems. Now let's talk about the performance. When running on similar hardware, our infrastructure with and without Asylo, which is the trusted execution environment, only has a delay in the building of our code. There is no significant delay in the deployment of the code. As TEE is a very crucial part of our development, the build time, the increase in the build time does not give us any decrease in our portability or in our efficiency. Now, talking about the limitations, one of the biggest problem is the only support for C or C++ languages. It does not support any other languages currently, but there is ongoing development regarding this topic. And the second most important thing is that our TEE, which is a trusted execution environment, is only limited to Intel SGX. It does not currently support other offerings from AMD or ARM. Talking about related work, this technology is actually not new, but there has not been a great adaptation in the industry due to the due to the availability of enough resources and integration support. But with Asylo, this problem is actually mitigated. So from this presentation, we can see that our whole CI/CD pipeline is actually very portable and reproducible as the whole CI/CD pipeline runs in Kubernetes cluster. Even the even the cloud providers do not have access to our build artifacts due to the usage of Asylo. And more importantly, we do not depend on any specific cloud provider. We are able to easily migrate our whole infrastructure from a cloud provider to even on-premise infrastructure. And thirdly, currently the only CVE scanner is the one offered by Harbor, which holds our build images. But currently there have been work going on for integration of third-party scanners like Clairvoyance. Thank you very much. I hope you liked our presentation.